Well, hello, everyone. My name is Tom Johnson, and I'm the director of the EOGOGIX Web Live programs. Having been involved in computer-based training in one form or another for more than the past 25 years, it's my pleasure to welcome each of you to this Web Live session. For those of you who may be new to EOGOGIX, I'll refer you to the About EOGOGIX page of our website. Suffice to say that the EOGOGIX team, led by KK Aurora, has been involved with many landmark telecom projects worldwide throughout the last 20 years. Now, let me introduce our instructor for today. Our presenter today is Frank Ortman, who is a principal member of the EOGOGIX telecommunications faculty. You can view his detailed bio on the website, but I'd like to say just a few words by way of introduction. Frank teaches the EOGOGIX courses on 4G, WiMAX, Wi-Fi, SIP, and VoIP. He also provides consultation on RFP design and vendor selection to those involved in implementing broadband networks as part of the BPOP program that's included in the Economic Stimulus Act. Frank's teaching and consulting career builds on his 20-plus years experience in telecommunications and electronic warfare. A firm believer in learning by doing, he even operated a small WiMAX network for a while, which is kind of an interesting tidbit. Frank has published several research reports and 4 books covering topics such as WiMAX, Wi-Fi, Voice over IP, and the emerging all-IP architecture. And now, without further ado, Frank Ortman.
Yes, good morning. Frank Ortman here, and welcome to my presentation entitled 4G Technologies and Services. And this is a non-technical presentation. And let's talk about our notices very quickly, get our housekeeping out of the way. The intellectual property rights remain the property of EOGOGIX. And let's jump right into this. And I entitle this, or should say I subtitle this presentation, Why Your Smartphone Doesn't Work the Way You Think It Should, a 4G overview. And I'm using the context of certain smartphones not performing to the expectations of some subscribers, and part of that might be that we're operating a 4G device on a 1990s network. That is a 2010 device on the 1990s network. So let's delve into that as to what are the shortcomings currently and what needs to happen in order for us to enjoy a true 4G experience. I like to go back to the parable of the blind man and the elephant. I've been going to telecommunications trade shows for over 10 years where even in the 1990s, 4G was the buzzword. And we were all told about the mobile experience and mobile data and how that's going to change our lives. I have no doubt that it will, or currently is for many of us, but I believe that a lot of what we saw kind of fits into the parable of the blind man and the elephant, of one vendor expressing their view of what 4G is, and perhaps another service provider offering theirs. And of course, they all have a telephone book's worth of acronyms to go along with that. This will be a largely acronym-free and vendor-free and even a service provider-free sort of presentation. So let's ask ourselves, what is 4G? It is largely a marketing term, and it's not a standard with hard and fast numbers as to speeds, technologies used, protocols engaged on that. It's a marketing term. So many industries and vendors have different paths to this, but there's all the common goal at the end. And quite simply it is, well, there's more bandwidth than you would experience on a 3G network, obviously. It is mostly mobile. Very importantly, it's an all-IP or flat architecture. This is a very significant step, and I'll go into that later in the presentation. And part of what that means is that there's no circuit switch voice, that it's all voice over IP. So is your smartphone as smart as you would like it to be? Are you having problems with dropped calls? This is we see this in the press here with the iPhone users experiencing dropped calls. And are the downloads not as fast as you think they should be? Is the service advertised as being 3G? And as I mentioned earlier, on the devices here, but perhaps the network has a little way to go. And what has to happen before those smartphones, as we know them today, can perform as well what we think we might be promised? Well, very simply put, the current architecture may not support the demands of the 4G network. I'm referring to the U.S. Some of the experience might be the same overseas. Here in the U.S., no telephone central offices have been built since the early 1990s. We were stuck at a very sort of fixed switching capacity based on our telephone central offices. And the distance limitations of 1990 cellular technology may not support new construction, new neighborhoods, office parks, shifts of population, and other demographics, in addition to servicing ex-urban and rural deployments. Well, we like to say it's the network. So there is no 4G cellular network today. Some would argue that the new WiMAX deployments qualify as 4G, but as far as upgrading legacy cellular networks in the U.S., no 4G cellular network exists today. We have a lot of bandwidth challenges at the cell tower, that is in the last mile. There are spectrum capacity challenges at the cell tower, also a last mile issue. And there certainly are bandwidth challenges to the middle mile, also known as backhaul. There may also be challenges related to the switching capacity at the core of the network. And across the network and ultimately the core are protocol challenges in transitioning to newer high-capacity protocols. Let's talk about the legacy cellular network as we know it today. The network was originally designed for a minimum quality voice for maximum capacity. And what do I mean by that? Well, largely we take a 64 kilobit per second voice, uncompressed voice channel, and we compress it down to something less than 8 kilobits. And the result initially, although we've made great progress on this, the result initially was a low voice quality. But this is actually the financial model around which a 1990s cellular business plan focuses. The matter of being able to have one base station, which might cost $500,000, be able to service hundreds of simultaneous calls, albeit compressed down to something less than 8 kilobit in order to satisfy the business demand. So what does that do to the maximum number of calls, at least cost in terms of the base station for bandwidth and switch capacity? So as I mentioned, the base station might have cost $500,000, and it was fed by a T1, or overseas that'd be an E1, from the telephone company, connecting to the telephone company's central office. And this might cost thousands of dollars. Again, so it's a matter of cramming as many simultaneous conversations through the cell tower, through the base station, through the telephone central office as possible at the least cost to the operator. Now, the introduction of mobile data is a serious challenge to the network as we know it, and I'll go into that. So, and that is really part of the disappointment for a lot of smartphone users expecting to have a laptop kind of experience on their smartphone, and the capacity just may not be there. So let's talk about the architecture. So certainly service providers are scrambling to perform upgrades to that 1990s network, but the last big build-out of the cellular network, particularly in the U.S. and also in Europe, was in the late 1990s. And the last big fleet of circuit switches were deployed in the late 90s, and after that there were really very few sales of circuit switches, which has led to the demise of the North American circuit switch vendors, namely Nortel is in bankruptcy. Lucent merged with Alcatel in order to maintain its market position. The radio access network is dependent on the public switch telephone network. So that is, sure you have the cell towers out there, but all the switching and all the smarts occur at the telephone central office.